Today we're studying the law of cosine. So first, let's write it down. It's c squared equals a squared plus b squared minus 2ab cosine c. Notice how it's very similar to the Pythagorean theorem. And I want you to notice that these are always going to match. Notice how it's lowercase c and that's uppercase c. So those are going to match. So take a moment to pause the video just to write that formula down, and then unpause once you're ready. Now the main thing to note for this formula, I will do this in red here. These letters are arbitrary. So I like the word arbitrary because it basically means like they're assigned arbitrarily. And as long as you fit the pattern, it really doesn't matter how you use them. So for example, I can actually rewrite this entire formula to say b squared. I could say b squared equals a squared plus c squared minus 2ac cosine of b. I could also say a squared is equal to b squared plus c squared minus 2bc cosine a. So notice how I can pretty much be flexible with these letters as long as they fit the pattern. That's what I mean by arbitrary, that you can have some flexibility when you're working with these formulas. So let's go to the first example. We're going to use the law of cosines to figure this out. So let's draw a triangle here. So again, just draw your generic triangle. A, B, C. A is 2, B is 3, and C is 60. I quickly want you to notice that you cannot use a law of sines here because there is no pair. Okay, so again, there's no pair here. So you currently cannot use a law of sines. And notice how it's side, angle, side. That's what this is saying. I sometimes call this an angle sandwich. That's a big indicator we're going to use the law of cosines. So we're going to try it right now. So I'll write it out for you. C squared equals a squared plus b squared minus 2ab cosine c. Let's plug it in. C squared, which we don't know, is equal to a squared, which is 2 squared, plus b squared, which is 3 squared, minus 2 times 2 times 3 cosine of 60. Now you will have a calculator for this section, but it is helpful to know how to do it by hand. So let's just work that out really quick. If you had a calculator, obviously just plug it all in, but since we can do this by hand, let's try it. 2 squared is 4, 3 squared is 9, minus 2 times 2 is 4 times 3 is 12. Cosine 60 is nice, that would be 1/2. So c squared is equal to 13 minus 6. So c squared must be 7. So look, we found it. C is the root of 7. And if you plug it in your calculator, you get approximately 2.646. Now to make it a little more precise, I'm going to use the root of 7 just because it's a really clean number. And now, notice how we actually can figure out the other angles because, let's highlight this right here. Look at that. By finding what C was, we now have our pair right there. So now I'm going to write on the side, I'll draw a big line here. We're going to use the law of sines. Now notice how there are two choices for A and B. This is going to be very, very important to get these questions all correct. So really put this in red. Use the law of sines to find the acute angle. It must be the acute angle. Now the reason for that is because last class we learned that when you use law of sines, there's some ambiguity as to whether there are 1 or 2 triangles. That happens when you're working with sine inverse. So to avoid that issue, we're going to always use law of sines to find the smallest angle. So I'll put acute, or think of it as the smallest angle. So looking at our choices, that means you actually want to find A. This right here must be acute or small. It must be acute. And that's because, look at this length. This length is 2. 2 is much smaller than 3, so therefore that angle should be smaller than the angle B. So we know if we find A, there's going to be no ambiguity. So let's start there. Sine of A over 2, that is equal to sine of 60 over root of 7. Let's multiply by 2. So sine of A is equal to 2 sine 60 over root of 7. We're going to sine inverse this, and we get A is equal to 40.9 degrees. Now remember, last class we always did the or 180 minus this answer, but we're going to deny this. There's no need to do this because we know the angle must be acute. It must be small because look at the triangle. It has to be a small angle. So by doing that, we avoid that need to do that 180 minus the angle to check anything. So I'm going to fill that in now. This is 40.9. So which means the last one must be 79.1.
I'll work on the rest of the problems and then continue on with the video.
Today we're going to finish up our Law of Cosine study. So you'll see I've already written it, the three main laws. I'll highlight this first one just because that's the one we're going to use the most. The other two are just the letters being moved around, like we talked about in class. There are two big notes we have to write down next to this. So put a big star. The law of cosines can find any angle. Meaning the law of cosines is a very powerful law, where the law of sines has ambiguity, meaning you have to do some extra work sometimes with the inverse function. The law of cosines, there's no ambiguity here, so it'll always find any angle. You don't have to worry about anything. Now the law of sines, that's where it gets a little bit tricky. The law of sines, when you use your calculator, notice how it always finds acute angles. So that's what I mean by the ambiguity. Like on the 9.2 part 2, we have to always check the acute and the obtuse angle by subtracting from 180. Notice how the calculator, it always gives you an acute angle. So today we're going to use that to our advantage. So let's go to our first example. It says use the law of cosines to solve an SSS triangle. So this is the first time we're going to be given no angles whatsoever. So let's draw a generic triangle. And again, we're going to label it just ABC. I'd label it like this. I recommend you do it too for later. Let's fill it in. A equals 4. B equals 3. C should equal 6. Now this is what we're going to do. Think about the restrictions I just talked about. If I zoom in up here, the law of cosines can find any angle, meaning it can be used to find whatever you want. However, the law of sines is going to be good at finding acute angles. And again, I really want all of you to highlight this idea of an acute angle. Knowing that, when we come to this triangle, this is going to be our first step. We're going to use the law of cosines to find the largest angle. It's very important because if the law of cosines can find anything, let's use it to find the one that the law of sines is a hard time finding. So again, we're going to use law of cosines to find the largest angle. So look at your triangle and think which one must be the largest. The largest one has to be right here. Now the reason that is because look at this. There's a 6. The other legs are 3 and 4. So this one, because it's across from the largest leg, must be the largest angle. So now we're going to use our law of cosines in reverse to figure out that angle. So we're going to write 6 squared should equal 4 squared plus 3 squared minus 2, 4 times 3, cosine C. Now from here, we're going to have a calculator for a question like this, so we're going to use algebra, meaning don't do arithmetic. I'm going to put a box around this. Imagine we solve for this box. The first thing we're going to do is subtract 4 squared and 3 squared. So 6 squared minus 4 squared minus 3 squared is equal to negative 2 times 4 times 3, and then cosine C. And again, imagine you have a box right there. Now to solve for that box, we're going to divide. Let's divide both sides by negative 2 times 4 times 3. So those are gone. So cosine C should now equal 6 squared minus 4 squared minus 3 squared, all divided by negative 2, 4 times 3. And remember, to get rid of the cosine, we're going to use arc cosine, a cosine or cosine inverse. So you cosine inverse all of this. So in your calculator, this is what you're going to type. Cosine inverse, and type in this exact expression. 6 squared minus 4 squared minus 3 squared, negative 2, 4, 3. Evaluate. You're going to get 117.3 degrees. Okay, so again, that's using your calculator once you type in that expression, and make sure your calculator is in degrees. So let's fill that in our triangle now. 117.3 degrees. So notice how the angle was obtuse. That means that's really good that we found the biggest angle, because now we know angle A right here and angle B right here, those two angles have to be acute. They have to be smaller than the largest angle in the given triangle. Which means, once we've done that, step 2 is use law of sines to find, actually really any, or like, I'll just write the second angle, to find the second angle. And it won't matter which one you choose, because they're both acute. So if you do not follow these steps on your homework, it's likely your numbers are going to get messed up. And you'll see that in today's classwork as well. I really want you to write these down. Follow these steps. Number 1, use law of cosines to find the largest angle. Number 2, then use law of sines. So now let's finish up the question. We can find any of the angles, it doesn't really matter. I'm just going to find B. So now that we have our pair, I'm going to write sine B over 3. That's equal to sine 117 degrees, 0.3 over 6. I'm going to multiply by 3. So sine B should equal 3 sine 117.3 degrees over 6. Let's sine inverse this thing. And then B is going to equal, so again, you type this exact expression in your calculator like we've been doing for this whole unit. And you're going to get 26.4 degrees like that. So you fill in 26.4, you do a little arithmetic, add that, subtract from 180, you get 36.3. And there it is. There's the complete triangle. Now there is a second method that some people do, so I'll briefly talk about it. I'm going to put a line here. The second or alternative method, sometimes people use law of cosines on every angle. So like I said, the law of cosines is a more powerful law. So instead of doing the law of sine second, some people just repeat the law of cosines method again, meaning they do the exact same thing that we did on step number 1 with B. So if you were to do that, you would just do this. 3 squared would equal 4 squared plus 6 squared minus 2, 4 times 6, cosine of B. And then you do the exact same thing, and then you're going to get B is equal to about 26.4 degrees. Now you can do that. I just know a lot of you like law of sines, so I think the law of sines method is pretty good. But I'm just showing you an alternative method. So here's our last example. Notice how it is no calculator. So let's quickly sketch a generic triangle here. I'll call this A, B, and C. Here's our little a, that's root 6. Little b is right here. That's 3 root 2. And c is root 6. We're looking for angle B, so put that right here. So it's a great application of the law of cosines. So you can write off if you want to. B squared is equal to a squared plus c squared minus 2ac cosine b. We plug everything in. 3 root 2 squared, that's equal to a squared, root 6 squared, plus c squared, root 6 squared, minus 2, root 6 times root 6, cosine of b. Let's evaluate. So 3 root 2 squared, that would be 9 times 2. 18 is equal to 6 plus 6 minus, this will be 6 right here, so that's 12 cosine b. Let's keep going. This is 18 is equal to 12 minus 12 cosine b. Let's manipulate this. So, no, let's just subtract 12. So 6 is equal to negative 12 cosine b. Cosine b is a negative half. Now here's the important part. There's no calculator, and that's because we can solve this in our head. For cosine, cosine hits negative half at 2 places. It would hit it at 120 degrees and 240 degrees. Now it's important that you understand 240 is impossible. That can't be in a triangle. So make sure you deny that answer when you're working with no calculator. 120 is our only answer. And we are done. So good luck on the rest of the problems.